And now we continue with the raster data. So the spatial data structures of the remote sensing imagery is called raster. So the pixel is called raster. And the basis of raster data is what we call as an individual grid cells. So for every grid cells, they contains the digital numbers or the brightness value, okay, and it only can store one value for every pixel. That's why for remote sensing image, we have one single image for the same shot, for the same scene, okay, for every bands. If we have 12 bands, 12 image in the same scene. For every pixel on the same location, they might have different digital numbers for every different bands. Okay. And what are limitations of the raster data? And this is what we call raster data basically. Each grid cells can only contain one number, and the size of raster dataset is large because each cell in an image must have a value that are recorded and stored. It makes sense because, as what we see in the previous step before, one data, one image, one scene from the lens set is about almost 1 GB. It's very big. One piece of image is about almost 100 megabytes because they have a lot of data for every band. Okay, that's why the size is very big. So this is an example here. This is the image, and you can see the pixels for every row and column here. For every dotted of the value, the brightness value, they contains this, the very value of the digital numbers. So this is what it means by the raster grid. Alright, and from this data, as we see, it's all black and white. Okay, then before we can do the pre-processing, before we can do the processing, we must understand the visual image display. Okay, the first idea is humans are adept at visually processing continuous tone that is analog. Okay, this could be in grayscale or in the color image. Therefore, to approximate a continuous tone image using digital data, okay, a brightness map must be created. A brightness map, basically a bitmap, is a computer-generated graphic display of digital numbers, which will be shown on the monitor. And considering satellite remote sensing, the number of bits per pixel is usually 8. Results a possible number 0 to 2255. It's the same like what we call as the image that we capture from digital camera. And the color coordinate system used by the monitor is the RGB. It's what our handphone, our computer use. And the precise nature of the display is controlled by the size and characteristic of a separate block of computer memory called a color lookup table. So these are the color lookup table. So the combination of RGB will create different kind of color such as cyan, red, and so on. This is what we will see. Okay? And due to the limitation of our human being, what we call it, physiology, only 3 image bands can be displayed at one time. And typical color composition used includes true color and standard color. However, you can have many other color composition from the multispectral data, right? But only 3 image bands can be displayed at one time. Why we cannot have more than 3? Because our eyes cannot see it. So the different combination of blue, green, and red with a different color will produce a different color. Okay, and of course, this is the Landsat 5 data. Band 1 blue, band 2 green, band 3 red. When you combine it together into a display from the visual image display here into its proper color blocks, it will give you a true color composite that you're familiar with. However, if you try to put it in different arrangement, okay, with the band-fold infrared to put inside red, what we see is a false color composite where it highlights the infrared data that we captured by infrared. So you can see the difference between the previous one, right? And now we go to the pre-processing. So what is pre-processing basically? Pre-processing is a process where we prepare the data before we can do the processing. Why we do that? Because remote sensing devices are not perfect. And the constraint of spatial, spectral, temporal, and radiometric resolution will introduce error in the remote sensing images. And this error will affect the accuracy of the human as well as the computer analysis. Therefore, it is very important for us to reduce the influence of the error prior to the analysis. And there are techniques to minimize. It's not that we eliminate the error. The error is still there, but we try to minimize as low as possible. Okay, minimize error prior to image analysis. This is what we call a pre-processing steps. So this is very important, image pre-processing, because before you can do any scientific complicated processing, image processing, you must go through the pre-processing to prepare the data before computer can process using different models. And after that, then you can put into products. There is information output. So in pre-processing, there are several steps, okay, and most of this is what we call as a image restoration. We try to restore the image, okay, as good as the real scene as possible. So the image restoration will involve correction of the geometric distortion, sensor degradation, and noise which were introduced during the imaging process. And restored images are geometrically and radiometrically corrected to match closely the radiant energy qualities of the original scene on that particular time, on that particular day. So, usually what are the errors in the remote sensing? Errors can be classified as internal or external. While internal, it could be created by the sensor itself due to the degradation of the sensors over the time and so on. It could be systematic, that is predictable, or it could be stationary, that is a constant. However, there are external errors related to the atmospheric and scene variations, such as unsystematic and non-stationary, which all of these are scene dependent. Alright, and after this, we will go to the image correction.